This exercise is related to the space-specific questions, and we did the first six questions already. So we'll start with question 7 today. You can use your mic or a chat to participate and state the answer, or sometimes you can also use a screen annotation. In the first part of question 7a, which list gives the astronomical objects in order of size, starting from the largest? Like we start with the largest and then the size decreases. So you can use the screen annotation. Use the screen annotation to select the right option, A, B, C, or D. So B is the right answer because what is the order? First we have galaxy, and inside the galaxy we have solar system. So for solar system, the main star is there, that's the sun, and then sun, around the sun the planets are moving, so they're smaller in size. So this is the order of from largest to starting with the largest, and then we decrease the size. In part B, the Earth and the Mars are the planet in our solar system. So how the planets, like they both are, Earth and the Mars are planet in our solar system, state two ways in which the orbit of the Earth and Mars are similar. Like what are the similarities in the orbit? Uh, for example, because most of the time in practical it is elliptical, but whenever you mention, you don't mention the planet orbital as elliptical. You will mention it is approximately circular rather than mentioning elliptical. If the question was the orbit of the comet, then why that case you should always mention elliptical, not circular. So this second point, instead of mentioning elliptical, it is slightly elliptical. So instead, but it is closer to the circular, so you can say it is approximately circular. So the orbit of the planets, so term should be mentioned. Yeah, it's relative basically is there. That is one thing, and then both of them orbit the sun. That's also the right. Another similarity. Can you find or work out another similarity? Two other similarities are they have the similar plane of orbit. Like it's not like, for example, if this is a sun, so if this is representing our sun and this is the orbit of Earth, then this will be the orbit of the Mars. So both are in the same plane. Like example, this is our Earth, then this is a Mars. So both are moving in the same plane. It's not like the planes are in different axes. They have the same orbits in the same plane. Another similarity that they're moving in the same direction or orbiting in the same direction. So orbit the sun, that is one thing, approximately circular rather than, so don't, for planets don't mention elliptical, for planets mention circular. And if it was about the comet, mention elliptical, don't mention circular. So another thing, they're in the same plane and they're moving in the same direction. But you have to write only two. So you can write any two. The first two are correct, but more points as you will remember. State one way in which the orbit of the Earth and the Mars are different. How these orbits are different from each other. You have to you have to work out the how orbits are different. Even from this figure, you can identify the orbit. You can see the orbital radius of the Earth is smaller than Mars. Like the orbital radius, the distance from the center to the Earth, from Sun to the Earth is smaller as compared to that of that you can mention. You can also mention they will have different time periods. Orbit, no, no, it's opposite. Earth is closer because you have Mercury, Venus, Earth, and then Mars. So Earth is closer. This is Earth, and this one is the Mars. So Earth is closer, not the Mars. It's Mercury, Venus, then Earth, then Mars. So the thing which you can mention, you cannot mention about the moons. You cannot mention about the moons as they asked only for orbit. So you can mention the size of the orbit. They have different size orbits or circumference. You can mention they have different radius of the orbit. They have different time periods of the orbit. Like take different time to orbit the sun. Yeah, Mars is having a greater orbital difference. Yeah, that fact is correct. That fact is correct. About the moons, so when you compare, you don't have to mention anything about the moon. Is it clear how the orbits of the Mars and Earth are similar and how they are different from each other?
Yes, sir, clear.
The next part, so we have Deimos is a moon that orbits the Mars, and the radius of its orbit is 23,500 kilometers, and its time period is 1.26 days. Calculate the orbital speed kilometer per day. So, like example, this is a planet Mars, and there is a moon which is orbiting the Mars, and the radius is 23,500 kilometer, and the duration is one point, and we need the answer in kilometer per day, so we don't have to convert the unit. But the thing what we have to do, we have to work out the orbital speed. So how to work out orbital speed of the planets? As the planets are moving in a circular path, so the distance move in a circular path is 2 pi r divided by t. So it will be 2 into 3.14 multiplied by orbital radius, that is 23,500, divided by time in days, because we need kilometer per day, so it is 1.26. What's the final answer when we work out the speed of the moon? So 2 into 3.14 into 23,500 divided by 1.26.
117,186.
So the orbital speed is 117,000. 126. Okay, 0.8. But if you read the question, we have to write our answer in two significant figure. Means I have to round off to two significant figures. So when I round off this number to two significant, like only two reliable digits should be there. So this 117, I can write 120. And then remaining all will be zeros. So it will be 120,000 kilometer per day. Because like these are the two reliable digits for us, 1 and 2. So as we convert like 117, we convert to 120. And then rest remaining all are zeros there. Yeah, why you have to round off? Because in the question they ask, your answer should be in two significant figure. Or I can also write like I can write 12 into 10 power, here 1, 2, 3, and 4. So I can write 12 into 10 power 4 kilometer per day. So that's how we rounded off to, because these are the reliable digits or the two significant figures. Is it clear to everyone, this question?
Yes, sir. Clear.
The next one, we have the moon of the planet Saturn, and it has a smaller orbital period to which is compared to Deimos. So Enceladus, which has a similar orbit, which has a similar orbital period is same, but its orbital speed is 10 times larger, suggests how this is possible. So the moon is there for the Saturn, and there is a moon for the Mars as well. The for a Saturn, when you compare the size, the Saturn is bigger in size as compared to that of the Mars. But they mentioned they have a similar orbital periods. Like if I say this is a moon of the Saturn, this represents the moon of the Saturn, and this represents the moon of the Mars. Deimos is a moon of the Mars, and Cladis is a moon of the Saturn. As I mentioned already in the question, this was continuation of the question. So they already mentioned about the Deimos is a moon that orbit the planet Mars. So one of the moon is orbiting Saturn, another one is orbiting the Mars. And they say both are taking the same time to orbit. Like the moon of the Saturn is orbiting or taking a same time. Like example, we work out, say this was given, the Deimos was taking 1.26 Earth days. So Enceladus is also taking the same time, which is 1.26. So can you identify which one will move, which moon will move faster, the moon of the Saturn or the moon of the Mars? Which one will move faster as they're taking a same time? Both of these moons are taking 1.26 days to complete one cycle. Yeah, that's good. The Saturn moon is moving faster. As you can see, it has to cover a greater distance. So it has to cover a greater distance. So orbital distance or a circumference of a Saturn moon is more than the circumference of the Mars. So it is moving faster. So it take a same time. Yeah, that's good. Like Saturn, which is a greater distance. So it is moving faster. The question is, the two moons are moving. One is moving around the Saturn, another one is moving around the Mars. As you know that the Saturn size is much bigger as compared to Mars. So means the moon of the Saturn is covering more distance, like it has a greater circumference as compared to the moon of the Mars. But they are taking the same time. So if they're taking the same time, 1.26 days. So my question was, which moon is moving faster? So the Saturn move is moving faster, and this is moving slower because it has to cover a smaller distance. So that's why it is moving slower and take 1.26 days. But the Saturn moon has to return back to the same place in 1.26 days to cover a greater distance. So it is moving faster. So idea, you have to mention that they have a different orbital radius. Like two moons have a different orbital radius, and the orbital radius of Enceladus, which is a moon of a Saturn, is larger, so it is moving at a higher speed. Is it clear?
Yes, sir. Clear.
As we consider the both paths are circular, so we don't have to mention anything related to kinetic and potential energy here. Here you have to relate that the moon, which is covering a greater distance in a same time, should move faster as compared to a moon which is covering a shorter distance. Yeah, that's the answer, because more orbital distance and a greater circumference for a moon of a Saturn, so it should move faster to cover that in the same time. Like if I say there is a race for two athlete A move, like example, 10 meters and then return back 10 meters. And the athlete A took 10 seconds to do this. And athlete B covered 20 meters and then returned back in 20 meters, but in the same time. So which one should move faster? So obviously athlete B should move, like run at a higher speed as compared to athlete A to cover the same, to cover, like to return back in the same time to cover a greater distance. So same idea here, that the moon of the Saturn is having a greater orbital distance or a radius or circumference. So it should move faster to cover in the same time as the moon of the Mars. So you don't have to relate anything about kinetic and potential energy. In question 8, these sentences are about the astronomy. Complete the sentence by writing a word. You can use the screen annotation to complete. So you have to mention the first one. One astronomical object smaller than Earth is. So here you have variety of the answer. You can mention like a moon, you can mention a comet, you can mention any like planet like Mercury, Venus, and Mars. You can mention Pluto, neutron star, dwarfs. Lot of possible answers for this one. Then two astronomical objects which are larger. So you mentioned Jupiter and Saturn. Again, this will have a variety of answer. Then also mention like a solar system. You can mention a sun. You can mention even galaxy, universe. Then the Milky Way. Milky Way is the name given to our. So the answer, the final answer is galaxy. The next one, this is a about the, as you can see, this is the orbit of the comet. So orbit of the comet is elliptical, or it is more eccentric, like having a curvature. The diagram shows the path followed by the orbit. Different positions are there: A, B, C, D, and E. State the name of a force that caused a comet to orbit the sun. So that's good, gravitational force. At which point shown the force on the comet is greatest, at which point it will experience a. So the answer here is B. Why the B? It is greater because B, it has to change direction, like greater change in direction. Like for a smaller distance, it has to greater change in direction as compared to any other point. That's why B is the right answer. So the next part, draw an arrow to show a direct. Draw an arrow at point D to show a direction of the force acting on the comet. So the force of the gravity is there. So at point D, when we want to draw the direction, so we will draw a direction from D towards the sun. Don't draw towards the center here because the gravitational force is due to the sun. So we will draw towards the sun. The next one, at which point shown does the comet have the greatest kinetic energy? This is a question in elliptical path. Which position it will have a greatest kinetic energy? A, B, C, D, or A? That's good. So it's B, because when it is closer, it has maximum kinetic energy and least potential energy. In question 9, a comet passes closer to the Earth. You can see, like, these are the position of the Earth we observe for 11 weeks. So this is a path of a comet. Like week 1, comet was here. Week 2, comet is here. Week 3, week 4, week 5. Then week 6 will be here. Then week 7, 8, 9, 10, and 11. And then the position of the Earth, week 1, 2, 3, 4, 5, 6, 7, and so on. As you can see, this is a scale is also like the units are also given, like which line is representing a path of the Earth and comet. Complete the path of a comet between week 5 and 7. Use the screen annotation to complete the path of the comet. This is the comet. So, yeah, good. Better make it, yeah. You don't have to complete for the because it's only week 5, 6, and 7, so you don't have to complete the this part. Only around this. The curvature, what you make, that's fine, but I think this one looks more appropriate. The reason is that it's because we have to make a sun as well. Otherwise, if I draw a sun, this is the Earth, so sun will be somewhat here. So according to this path, the comet might crash to this sun. So this path, the red and the green lines are more appropriate. The next one suggests why the astronomer did not observe the comet in week 6. Like from your diagram, you can identify why the comet is not observed in week 6. Week 6, it will be here. Can you say, like, we are here on Earth, we are at this position, and the comet is at this position. Why we are not able to see this comet? So that's the right answer. That because the sun, it's like behind the sun. Yeah, that's the right answer. The comet is behind the sun, so we are not able to see this comet. If it was in front of the sun, in week 6, if it was in front of the sun, we will be able to see. But this comet is behind the sun, that's why we are not able to. Some objects behind the sun can be seen. That's true. With that is because the gravitational pull, yeah, that's a space time, and the gravitational pull cause a light to bend. Like gravity can cause a light to bend as well. But as the likely reason here that why we are not able to see is because it's behind the uh, opposite side. Instead of saying behind or front, it's better term. It's opposite side of the sun. That's the most appropriate, because behind and front it's not appropriate for. So the question is, in week 6, basically week 1, this is a path of a comet. This is a comet, and this is the Earth. Okay. So week 1, Earth is here, comet is here. And when we complete the path of a comet, so week 6, the comet will be here. And where is the sun? So this will be the sun. So the question is, why in week 6 we are not able to observe the comet? So this is our sun, this is the Earth, and here is the comet. So comet is on opposite side of the sun. That's why we are not able to observe it. If the comet is like in week 5, we will be able to observe. But week 6, why? Because it's exactly opposite side of the Earth. Like Earth is on the right, the comet is on the left. And in between them, there's a sun. That's why we are not able to observe this comet. Why we are able to see some objects? It's mainly they're not exactly behind the sun. If some objects are here, so we will be able to see them. But if they're exactly on the opposite side, we won't be able to see. Like what normally happen in a lunar eclipse as well. The observation shows the comet near to Earth was made during. Yeah, it also depends on the position where you're observing a comet from the Earth. That's true. The observation showing the comet nearest to the Earth was made. So, which position the comet is near to the Earth? Can you identify like which week the Earth and the comet are very close to each other? From this figure, you can identify. Like week one, this was a distance between them. Week two, week three, week four, week five, week six will be like this. Week seven, week 8 and week 9. So you can see week 9 it appeared that when you check the distance, week 9 they are very close to each other. The distance between the Earth and the comet is smaller compared to other parts. So answer we will select option C, which is week 9. Explain how the diagram shows the speed of the comet changes as it moves from position 1 to 5. As the comet is moving from position 1 to position 5, how you can say that the direction of the like the speed of the comet is changing. So you can refer this with a gravitational potential energy and kinetic energy, because one thing, yeah, that's good. One thing you will mention, because the potential energy, the total energy is constant. No, from week 1 to week 5, the question is how we can say that the speed of the comet is increasing from week 1 to week 5. That is the question. So how we can say that speed is changing from week 1 to week 5? So the total energy is conserved. So total energy is always conserved, means the sum of the potential energy and the kinetic energy should be constant. When the comet is moving from position 1 to 5, what happened to its potential energy? Increase or decrease? Moving 1 to 5,
Decreases as it goes
closer. So it
near to the
decreases.
object.
So it goes closer to the sun, it's decreasing, so means the kinetic energy increase. If the kinetic energy increase, it means the speed of the comet will also increase. So the mark distribution, you'll mention the total energy is conserved. So when the comet is moving closer to the sun, its potential energy is decreasing. So kinetic energy is increasing. As a result, the speed of a comet will also increase. Suggest why the speed of a comet changes. So how, the part 5 was actually there, like the same idea is that, and you can also identify. It's a similar answer, like suggests why the speed of a comet is changing. Here you will mention the total energy is conserved, potential energy is decreasing, kinetic increase. The next one, why the speed is increasing, changing, as the kinetic energy is increasing. That's why the speed is changing or speed is increasing. The Earth orbit the Sun once in 365 days. So that is the orbital time. The radius of the orbit of the Earth, which is also known as 1 astronomical unit. which is 150 exponent 6 kilometer. We need the answer in kilometer per hour. So distance we don't have to convert, it's already in kilometer, but time we have to convert into hour. So 365 days, I want to convert into hours. So what we'll do?
Multiply by 24.
So 365 are there, we'll multiply by 24, so we'll get the total number of hours in 1 year. And
So, Mr. It's
to get the orbital speed, yes, speed is equals to 2 pi r divided by t.
1760 the total hours.
Okay. Then 2 into 3.14 into radius. We don't have to convert because we need the answer in kilometer. So it is 150 into 10 to the power 6 divided by the time, which is 365 times 24. So when we simplify this, it's about like 110,000 kilometer per hour. That's a speed at which. So the rounded off answer 110,000 kilometer per hour. That's the orbital speed of the Earth. Is it clear?
Yes, sir. Clear.
The next question is, descriptions are given. We have Gliese 832c. We have hog objects are there. We have honks and we have I naught or I zero. It's the first one. Which of these is a comet? I will show you all the options. So as you can see, like elliptical orbit is there, so that's right. That this one should be a comet. Then the next, which of these is a galaxy? The next part is which of them is a galaxy? You can use the screen annotation. A large collection of billions of stars, that's good. So because billions of stars collectively, they will form a galaxy. And the first one, because they asked which is a comet, so from elliptical path, you work out that this should be a comet. Then orbit the planet Jupiter in almost circular orbit, so it means this should be a moon. And orbit the star, so it means this should be a planet. So remember one thing, like always consider the orbit of the planets to be circular and the comets to be elliptical. The last one, which galaxy is our solar system in? A cartwheel, a Milky Way, sombrero, or sunflower. So the our galaxy is the Milky Way galaxy. So this was like from question 7 to 10 about the space physics. Next session, we will do more questions from this.